Welcome back to the internet. This is a project that I'm dusting off, quite literally, because I was working on the Freevalve Miata. I was doing some changes here and there and kept getting frustrated. We'll go over a few reasons why here in a minute, but we're going to start off with something new on this and something very crazy. I put Freevalve in the title. We're straying a little bit further away from that than I think I intended, but in spirit of this, it's definitely something a little bit different. So right off the bat, a few things. I have done absolutely nothing to this motor, so I have to get this all cleaned up, and I found miscellaneous pieces, parts to put it back together, but I have no idea where the retaining clips for the other side of the rockers are, so that's a fun thing. I have not fired it up. It probably still has the original gas from, oh yeah, original gas from in there. It's great. So I'm gonna kind of put this back together a little bit, give her a couple of pulls, make sure she fires up. We don't have any problems there, and then I'm gonna get it stripped down and start taking measurements off of this, and we'll go through a few of the problems that I had earlier, and we'll get this all put back together. So yeah, get a haircut. Alright, so we got a spark plug in. We got one exhaust manifold nut on, because I couldn't find the other one. We have O-rings and circlips, because I couldn't find those. And a wrong bolt here. Let's see if it fires up. It should. I'm going to put it on the ground. Switch that makes electricity happen on. This is domed at the top here, so pretty much anything that we're going to do is going to have to be up here. I guess we're going to get started on this. Step one is the bolt pattern right. Yes, it is. Love it.
All right, let's talk flaws with the first design. And the first design is actually like the 30th design, but ignoring that for the moment. First of all, the code. Wow, that was bad. It had a lot to do with air is very hard to control. So just central unit of valves in the back, terrible idea. That means unequal length up to the front. And like the frontmost cylinder had a significantly longer piece of tube than the backmost cylinder. So that had a completely different timing situation. I ended up putting in an air squishiness formula, which, yeah. Also, air is warm sometimes, so combining that with also putting it in a environment which one side of the motor, the intake side, was relatively cool for what it was, and then the exhaust side right above the exhaust was very warm. Adding to the list, I was never super happy about the valve guide attachment. Where it connected to the valve was actually great. I had no problems with that whatsoever. Where it attached to the pneumatic cylinder, I wasn't super thrilled with. I don't have $1 million testing equipment or anything, but I think I'd see some adverse wear there over time. And to that point, the solenoids that I used were rated for 140 degrees Fahrenheit, which it's Phoenix, so it's basically that right now. And I blew that out of the water. I got some really high temperatures on there. It also mentions on the spec sheet that anything over 100 hertz needs some temperature control, and I had none of that, but they all survived, so. So with that, I really kind of lost steam on the air design itself. I was working on a design that combined both a magnetic coil, like I was experimenting with in the Miata video, with the compressed air, using the compressed air to do all of the work, and then using the solenoid to do the fine tuning. So really one of my major complaints about this is the valve itself, because not only do you have to get that valve moving down and opening, you have to get that valve coming back and closed. So you put a spring on it, and not only do you have to close it, but you have to close it fast enough to where it closes in a reasonable amount of time and consistently presses up against the camshaft. So your spring has to be heavy enough. That's more force that requires the cam to spin around. That's a whole thing. The desmodronic valve system was a way around this. What they did was they actually had an opener and a closer lifter on a cam, which is actually a pretty cool design. They require a lot of care and feeding, as any Ducati owner will know. So let's recap really quick. Moving the valve is hard, and I don't like it. We need to control the airflow. I'm tired of dealing with squishy air. Let's redesign the entire thing and see what we can do. So after a little bit of messing around, this is what I came up with. It's basically a knife gate, but it's attached onto the shaft of a stepper motor, so I can control position. I'm gonna do a little bit of testing here and there and get this put together to really see how it's gonna look. So considering all of this, I actually went through and used the SolidWorks flow tool to figure out if this thing's going to flow. And somebody, I'm not going to say who, during assembly, did not line everything up. So obviously those two things are supposed to line up and everything's supposed to be happy, and they don't. But in the name of, let's see if this works, we're going to continue to go through with it. For the sake of entertainment and for the sake of my sanity, I put the intake at just like a partial open, and then the exhaust valve as open and free and clear as it does, and it looks like spaghetti. As I thought, we have an eddy problem. Air's going straight down, bouncing back up, and getting stuck in that little crevasse right there as that's flying open. I'm not actually sure that's going to matter, because as that piston goes down, it's drawing that air in, creating a vacuum, so theoretically, by the time that piston reaches the bottom of its stroke, it should have that valve closed, so it can't go anywhere anyways. But yeah, so that's the flow simulation so far. Welcome back to the surface of Mars. It's about 114 degrees in Phoenix today, and it feels every bit of it. So now that I got everything sitting here, let me explain my thought process a little bit. I took off the head of this, and this is pretty much standard. I just took off the gas tank and stuff like that, because we're not going to need that today. Because I have total valve control, I should be able to run this on compressed air, and then if this works, I will machine that out of aluminum and go from there. As you can see, the air versions are quite a bit wider, just because we are running only in a 2-stroke configuration, not a 4-stroke. We don't have an intake, nor do we have a compression stroke. So, these are made in 3 pieces, so they're machinable when the time comes for that. And then they're bolted together. Today, we're going to be using our Lord and Savior black RTV silicone to try and get a seal on all these, and we'll see how that goes. Some standard stepper motors and some stepper motor drivers running with the Arduino. The other thing is, this was the original timing wheel on the original Harbor Freight Freevalve build. We're not using this. We're just going to use the one off the Freevalve Miata. This is just a flying Miata 60-2 timing wheel, so that works pretty well there. I think that's all the shortcuts that I took. All right, let me get this assembled. Let's see if this works. Alright, so we got these kind of set in here, and you can see the general idea that I'm going with on these. Of course, it's PLA on PLA, so I use my secret formula of varied German clutch grease, and we'll see how that does. I hate these dowels already. I'm gonna do something different with them, but let's see if we can get this to work. Alright, through a fun amount of spaghetti, both of these are drawing about an amp, and should be plenty strong.
So I'm going to get these mounted up, make sure they work, and make sure they spin these, and go from there. Alright, while we continue to have complete spaghetti when it comes to wiring all this up, I still don't have a crank position on there, but both valves do spin together when they're plugged in. What I did was I marked the end of the stepper motors there to get position on where those valves are turning, or the position of those valves. I think eventually I will probably put like a top dead center, like a true cam position sensor on there instead of just counting steps, just for reliability. But other than that, it's working right now. Never really showed the Hall effect sensor in the original video. It slides into this little holder and then has these 3 pins that sit on here that can go on behind, and then this sits on there like that. Alright, so I got it all assembled. I'm not super happy with this still. I'm still missing some teeth occasionally, which is a problem in the current state that this code is in. I'm not doing anything fancy except having the speed of the flywheel to these, and counting the steps on the stepper motors to see revolutions and stuff like that. Usually I put code and stuff in the comments and 3D CAD files in the comments, but that's probably not going to happen this time because this isn't great. It leaks bad. Yeah. So I've been messing around with this a little bit, and it does okay. I skipped past a lot of the tuning stuff because it's adjusting valves back and forth a degree to figure out where it's actually sort of happy. But the important thing that I want to showcase here is that it does work, admittedly not well because of all of the flaws. Got about 70 psi going to it with the air hose. I'm firing it up with the drill. This just needs to spin fast enough. I actually have it turned off to where it won't spin these until this reaches a certain RPM. Because if these lose count of steps, or if this lose counts of steps, I have to retime the entire thing. Yeah, the proof of concept. It's a proof of concept. It's so hot out here today. Alright. Okay, let's give her some air. There it is. That did not sound good. Okay. So, yeah, I think that would be the problem right there. That's supposed to be attached, and it's not, so. Well, that didn't exactly go according to plan, but you know what? For right now, it works okay. Like I said, I don't think I'm going to put the files in the description below just because I'm not super happy with this right now. I'm going to go through, I'm going to fix some of the flaws, I'm going to fix a few of the things that are bothering me about it, and then I'll probably do one of these out of aluminum and retry the test with a better timing wheel, sensor and stuff like that, and see what I can do there. But I'm happy with the control software. This is working well. I'm happy with it overall, I think. But it just needs a few things to really get dialed in. If I can tighten up the tolerances, add some seals, add a little bit better control and strength to a few parts, it'll do okay. I think that'll help a lot, but overall it's not bad. It worked. I wish it worked a little bit better, but this channel is 90% experimentation, and yeah, it's kind of fun. So if you like this video, please like, subscribe, stuff like that, and thank you very much for watching.